This is the first video for section 7.2, which is about composite functions. When we're talking about composite functions with trig and inverse trig functions, we're doing nothing more than thinking of Fogg and Goff like you typically deal with quadratic and cubic and rational and square root functions. Nothing is different, right? So with your typical Fogg and Goff functions. So you have this example over here to the left. You take the f function, plug it into g, or you take g and plug it into f, right? And so you're going to do the same thing with trig and inverse trig functions. So in this case, the example we have here, we have arcsine as one function and sine as the other. And so for Fogg or f of g of x, you take sine of theta and plug it in for theta in arcsine, or vice versa, you take arcsine and plug that in where theta is into sine, and then you have your composite function. So you don't deal with it any differently than you would any other standard composite function that you already know how to mess with, right? But there are, kind of two main categories to these composite inverse trig functions. There's the case where the trig functions are the same and where they're different. So we'll start with when the trig functions are the same. And in that, underneath of that kind of main umbrella, there's the case where the arc is on the inside or where the arc is on the outside. The general rule of thumb when dealing with composite functions where the trig function is the same, the answers when the arc is on the outside, they come from the domain of sine, right? So your answers are going to be angle measurements, right? They're going to be pi over 2, pi over 4, right? So answers come from, that's what that little sign means, it's just an element of. Answers are from the domain, and the answers are angle measurements. Right? Answers are angle measurements. So example, pi over 2, 5 pi over 6, pi, things like that. And then in the other case, when your arc is on the inside, your answers are going to come from the range of sine. So our answers will be things like root 2 over 2, root 3 over 2, 1, 0, things like that. So our answers are just are the y values from the ordered pairs on the unit circle, right? They are the y or x values. They're y values if you're talking about sine, x values if you're talking about cosine, right? But just like with any function, composite functions have domain restrictions as well. So this chart over here, it gives you each instance of a composite trig function for the three main functions, sine, cosine, and tangent. And over here we have the legal values of theta, or just, the domain of theta in this case. Right? And for the first Quizle question, I want you guys to try explaining to me why these would be the only values that can be plugged into these composite functions. And in order to kind of help you think through that, I want you to work with a specific example. I want you to pick a value outside of 0 to pi and plug that into arc cosine of cosine and see what happens. So, pick a value, negative pi over 2 or 3 pi over 2. Figure out why one of those values don't work. And then from that example, try and explain to me the first part of this question. All right, so let's do some actual examples. So when we're talking about composite functions, we start with the inside and we work our way out. Right? We start with the stuffing and then move on to the turkey. I think that's what you guys talked about when you were first talking about composite functions. All right, so the sine of pi over 3. Well, we need to ask ourselves, well, what is the sine of pi over 3? You should all know that by now. The sine of pi over 3 is root 3 over 2. So in that case, I'm left with sine inverse of root 3 over 2. So now looking at this, you have to ask yourself, where am I on the unit circle where my y value is root 3 over 2? Well, if you come back up here to our domain chart, we're dealing with arc sine of sine. So the only values that we can plug in are values between negative pi over 2 and pi over 2. So within the first and fourth quadrants, so if this is pi over 2 and this is negative pi over 2, then somewhere in one or the other of these two quadrants, we need to have the value of root 3 over 2. Well, we just saw that the y value of pi over 3 is root 3 over 2. If we did the y value of this one down here in the fourth quadrant, we'd have a negative y value. So we are at pi over 3 when our y value equals root 3 over 2. So in this case, this equals pi over 3. Okay, let's move on to cosine of arc cosine. Well, where am I on the unit circle when cosine equals 1/2? Well, if you think back to the all stupid trig crap, think back to that, then we know that cosine is positive in the first and fourth quadrants. But when we're talking about the inverse of cosine, remember we restricted the domain of that to 0 to pi so that we could have an inverse, because you can't have an inverse unless your function is 1 to 1. So in order to do that, we restricted the domain of cosine to 0 to pi. All right, so then that means that our answer, so the cosine inverse of 1/2, must come from this first quadrant. Well, where in this first quadrant is my x value, because we're talking about cosine, where is my x value 1/2? Well, I know it's not going to be the pi over 4, and pi over 6, that x value is root 3 over 2. Pi over 3 has an x value of 1/2. So now I have cosine of pi over 3, because this part here equaled pi over 3. And so now you just have to ask yourself, well, what's the cosine of pi over 3? Well, we just saw from the inverse of 1/2 that equaled pi over 3. So in this case, the cosine of pi over 3 is actually 1/2. Right, so see if you notice anything interesting about those two, and take a shot at question 2. You're going to find the exact values for A and B. Make sure you're taking into consideration the domain restrictions of sine, cosine, and tangent that we talked about in section 7.1. All right. Now there's the case where your trig functions are different. We're going to start with when the arc is on the outside. The case where the arc is on the inside will be in video 2 for section 7.2. So when the arc is on the outside, I mean, you're really not doing anything different. You're going to work from the inside out. You're going to find the value of the inner function and then arc that value. So if we do example 2, well, what's the cosine of pi over 4? Well, the cosine of pi over 4 equals root 2 over 2. So now I'm left with the arc sine of root 2 over 2. So now we have to ask ourselves, where am I on the unit circle where my y value equals root 2 over 2. Right, well, I'm actually, my y value, so we have all stupid trig crap. So my y values are going to be positive, sign is positive in the first and third quadrants, but don't forget the domain restriction on sign meant that the domain of sign when we're talking about arcsine is from negative pi over 2 to pi over 2, which means that our answer cannot come from the second quadrant. Right? So then that means that the arcsine of root 2 over 2, so the place where we are on the unit circle when our y value is root 2 over 2, is pi over 4. Right? So our answer is pi over 4. Right? So try Quizle question number 3, find the exact value of that function, and that's it.